Morning and welcome to the second metadata lesson on generating a metadata record in Michka, following on from the first video of the mandatory minimum elements required for the Inspire Implementing Rules directive. So we're going to take the simple metadata record we generated earlier and work now through what can be called the metadata best practices. So now that we have our metadata record that's valid and we've edited it, and everything on the right-hand side is now valid in terms of minimum elements, the best practice now is to go down through each item in detail and provide the information that's required. So starting at the top, the resource title is basically the name by which your cited resource is known. And it's a free text element. In this case, it's mine to see, work package 3, seafloor, massive sulfide deposits. Resource abstract refers to a brief narrative summary of the content of the resource. It's recommended that this is a summary description of your data set in not more than 500 words. The resource type, in most cases, is going to be a spatial data set, or if it's going to be a series of data sets, it will be set as series, or if it's a service, it's a service, or in some cases, maybe non-geographic data set. So data set, that refers to point geometry, polygon geometry, polyline geometry, raster imagery. The resource locator will refer to the URL web address of the resource online. This will, in our case, refer to the EGDI platform, data platform, where data exists and has been published. So here I am in the EGDI platform. I'm logging in as a user and I'm finding the resources associated with mine to see. So I basically go here and I look at web maps and I search for mine to see and I run the EGDI mine to see web map service. So here you can see there's a geological map 1 to 1 million, geological map 1 to 5 million. There's a bathymetry data set, so on and so forth. For that example, actually, it doesn't match the requirements of the video. So I'm going to go to the mine to see preview web map service where previous mine to see metadata has been generated. So here we have seafloor deposits and we can take the location of the seafloor deposits data set. Should be able to find the URL for that. And you input in the URL here. The function of the link is that it provides information. The protocol is it's a www link, and then this is a description of what data is available from that link. So it's seafloor, massive sulfide deposits, and a description of what SMS is. SMS are sulfide deposits in large extent on the seafloor. The unique resource identifier is a URI to the EGDI Metadata Catalogue that uniquely identifies that resource. Text again, seafloor massive sulfide deposits. Code space, you can say, is Michka URI. The resource language is the language that's used within the dataset. In this case, it's English. The topic category refers to the main theme of the dataset from ISO 19115 topic category codes. So these are a list of code lists that are provided. You can provide more than one. So here you have geoscientific information. I recommend that you do use more than one. So you have environment, In the case of marine, there should be oceans. And there's also other ones like boundaries or economy. So seafloor, seabed minerals is related to the economy because it's all about mining and seabed mining. So they're examples of 4 topic category codes that can be used for mine to sea data sets. Keywords are very important. So basically keywords are around the type of keyword describing the data set. So it's very important that you provide an inspired data theme keyword. So there is a code list provided by Michka following all the inspired themes. So in the case of GeoEra, we're looking at geology as one theme that's important. And we're also looking at mineral resources, which is another theme. In our case, in the Mine to Sea project, we're looking at mineral resources. We only need to provide one inspired data theme for our metadata record. The next keywords are the GeoEra keywords from the GeoEra keyword thesaurus. So basically, there is a link to that thesaurus that allows you to search for words or terminology associated with the data set. So in this case, it's seabed is an example. You can double click there. Seabed is a keyword. You can have one or more different keywords here. Sea is another one. So we can look up words like minerals. There's nothing there. Say metals. So there's metal. So there's an example of 3 keywords coming from the thesaurus for GeoEra. The project name then will reference one or more of the selected projects that data is associated with. So you can see here the list of all the GeoEra projects. In this case, it's Mine to Sea. Double click to make sure that your record is there. Then we go on to the spatial scope. Priority data sets only reference, sorry for this here. The priority data sets only reference if your data set is being reported to one of the INSPIRE or European directives. The only area of geology that would be of note would be the groundwater reporting under the Water Framework Directive. So I wouldn't be too concerned about providing a INSPIRE priority data set. What is important though is that you provide a spatial scope data set. So that lists at what level your data is collected. So in Mine to Sea, it's European, and we use the keyword European from the code list. Any extra keywords that you'd like to provide, free keywords, can be added here. So here I have an example of discipline keywords. So geology and earth science are disciplines. So you can provide them there. You as a user can define what keywords you want there. More details on keywords can be found if you look up ISO 19115 keywords. You'll see that you can have theme keywords, place keywords, discipline keywords, stratum keywords, and temporal, referring to time keywords. The geographic location of your data set can obviously be set by the bounding box, or you may know the extent of your data, so that will show you from the map viewer there. The geographic identifier in this case you can choose as Europe. The presentation form is important for data. So in most cases, right, it's either going to be a digital map or a digital image. In some cases, maybe videos. In other cases, maybe models or maybe tables. So in this case here, for Mine to Sea, it will be digital. So you will choose document digital. The edition might optionally refer to the version number of a model. So it might be model version 1 if it's a 3D model, version 2, etc., etc. Reference dates refer to when the dataset was published to EG. So you would do this for the publication date on the EGDI data platform. Resource temporal extent, you can look at the filling instructions. So basically that's the begin date and the end date for your data set. So when did you start collecting it from and when was the last collection date? If there is no end date and the data is ongoing, then you just enter now in the corresponding field. The lineage is important in terms of giving a general explanation as a data producer and your knowledge of how that data set was generated. So in my previous video, I explained in steps 1 to 5 or 1 to 10, how you generate that data. The scale comes under spatial resolution. So that's the level of detail. In the Mind2C project, we are collecting data at a scale of 1 to 200,000. So it's important that the user knows should be able to select that there. The distance units, there you can select one or more values. So in this case, it's meter. So it's 1 meter or 1 centimeter on a map references 200,000 meters or centimeters in your map. The conformity, as I explained in the first video, is around the conformity of your data to the Inspire specification. And you choose Inspire interoperability 1089/2010, and the degree of conformity. In most cases, it's not evaluated yet, or it's no or yes. So you have a choice, but it's recommended for the moment that you use not evaluated. I explained that conditions applying to access and use of the data will be the Creative Commons BY 4.0 license, which is the adopted license for the GeoEra program for all our data sets. And then you have a link to the URI for the license, which explains in more details the rights and requirements associated with that license. For limitations on public access, it's recommended to have no limitations to public access, which is the Inspire Directive's best practice guidance. The responsible party obviously is the person who's responsible for that data set. In this case, I've just used an example from one of the project partners in Mind2C. So you'd have their details, their organization, delivery point, email, telephone number. And if you want a link to the Mind2C project or that person's personal page, that can be provided there. The role will obviously be set to custodian. The data quality scope refers to the level at which the data set, or it's a hierarchical level of the data specified by the scope. So in this case here, it's a data set or a series. So in most cases, it will be data set. The coordinate reference system. Inspire requires the ETRS 1989-4258 EPSG code, coordinate reference system, but in most cases, users are probably going to be publishing their data in WGS84, which is 4326. The vertical reference system will only refer to 3-dimensional data. So that's where you're dealing with depth values or height values associated with your data. So in the case of depth values in the marine environment, it'll be local depth based on a local datum. So it may be between -5,000 and -10 meters, which would be the depth of waters in the North Atlantic Ocean in the Irish continental shelf boundary. The vertical extent reference system will then obviously reference that vertical datum, so that's local depth. Then the distribution information, most cases is recommended to be either geopackage and shapefiles for spatial. So you should have shapefile as a choice. Some other people may submit CSVs or KMLs or atoms or GeoJSON. So there's a code list there provided for you to choose that. And then obviously you might have a version number based on the software you're using to generate that metadata record. Spatial representation type, again, is a code list. So for point geometry, polygon geometry, line geometry, it's vector. For raster imagery, like a GeoTIFF or other form of raster data sets, it's grid. For anything like CSV files or spreadsheets, it's text table. And if in some cases you might have a video, it's a video. The maintenance and update frequency references, right, information about how often your data is maintained and updated. So in the case of Mind2C or any project, you're really setting it at annually or some form of sub-annually. Biannually means twice a year, quarterly means 4 times a year, monthly means 12 times a year. So we'll just choose annually as our example. Or you could have a user-defined frequency, which could be automated every 5 hours, maybe every 3 weeks, for example. The purpose of your data set is a summary of the intention of why your data was generated. So in the case of Mind2C is to gain knowledge on seabed minerals potential for exploration in European waters. The metadata point of contact is the detail of the person who generated the metadata. So in this case, I've just referenced again from the code list, the name of a person in the project, in the Mind2C project. Again, the check survey provide control access to the code list, so we can add more names to the user list of points of contact so that you can automatically search for your name or some name of a person from your specific project in that list of people available. So that will auto-generate in then that person's associated organization name, and so on. The file identifier is again the uniquely resourced identifier, and then it's very important to reference the parent metadata record, and then you can select from a list of metadata records if there is a parent metadata record associated with your project. So here I will try and search for an example of a Mind2C one. There you go. So there's the parent metadata record for this one. And then sources, the final element is sources used for the resource citation. So again, you might have some sort of project that you might want to link in to the sources there. Always ensure that your valid elements are green on the right-hand side and not red. And that is an example of how to implement best practice concerning content for a metadata record through Michka that can now be uploaded to the EGDI platform. So now we're going to save our metadata record and we're going to stop working on it. And that's our metadata record generated. So the important thing now is to take note of your metadata record and the URI address in the bar here. So if we go back to the EGDI main page and I search for all the metadata records, and I click on this one, this now has the basic link to my metadata record that I've created following best practices around. And it's always good practice to check your content after you created it through this user interface here. See that you've got all the details that you require and links to coupled resources if there are any, links to the Inspire interoperability, and links to all the keywords here you can see. So click on those links here, they will bring you off to thesauri that you've used to describe your data. So moving to the EGDI data platform, it is mandatory that when you upload your data set to the EGDI platform, i.e. you're uploading your geo package, you must have an appropriate metadata record created by Michka to associate with your geo package or your geotiff or your shapefile. So when you are uploading your geo package or shapefile, it is required that you provide the metadata URL from Michka in the metadata URL. And then you simply just upload your data set. So in this case, it's a geo package, it's a .gpkg file. Make sure it's visible here and then click the upload button. And your geo package with your associated metadata record now is visible. So allowing you to select your data layers from your geo package for the map interface on the EGDI platform. In this case here, we're going to upload the seafloor massive sulfide deposits geometry points, and we're going to show the field deposit name in our map. We're going to add it to the Mind2C preview map. Once that has been chosen, we click on import, and the data set then is imported into the map. So now in our web map for Mind2C, which we've created, we run the Mind2C preview. You'll see the seafloor massive sulfide deposits web service is now visible, and this data will only upload to the EGDI platform once your metadata in Michka has been created and the URL, as you can see here, has been made available. I'd like to thank you for attending these session videos on creating metadata. and look forward to hearing from anybody. If there's any concerns regarding queries for technical support, Pavla and the Czech Republic team are available to the GeoERA partners for more details regarding the generation of niche chem metadata.